All right, hello everybody. For our group project, we created a traffic light control system. So we found that microcontrollers are commonly used in these types of systems. One advantage of using microcontrollers for these systems is that you can adapt different sensors or timers to effectively move traffic how you want to in different urban environments. So what we have done is we have based our model off the 600 South Street that comes off the freeway in Salt Lake City, Utah. And this specific street uses timed sensors to ensure that the traffic moving off the freeway does not get backed up in the lights. So our project goal is to demonstrate the adaptability of microcontrollers in urban traffic management. So we're going to go ahead and show you our physical build as well as our virtual build, and then we will go ahead and talk about things that we learned along the way. And our group members consist of Barrack Willard, Eli Van Tassell, Michael McCleary, and Zach Burt. So thank you guys for watching.
Hello, my name is Eli Van Tassell, and this is our walk-we simulation I'm going to be going through. First off, you can see to the right, we have an LCD screen, an Arduino Uno, a few breadboards with LEDs to simulate intersections. Over here in the code, you can see how I initialized each pin for red, yellow, and green, and I assigned them each to a pin number. Each pin number is set up, as you can see here in the void setup. Same with the LCD initialization, backlight, and over here you can see where the system starting, which will, when we go through the simulation, you can see the loop. We iterate through 4 cycles, and it'll continue to iterate. Some more LCD just printouts to see where in the cycle we are. Continuing down, added some comments, but we can see where where we want the green lights to be active and red for the others when that green is active. We print out that the green is on. We also have a delay between each of these. And then for the yellow phase, we can see just when it's not that green or red, it'll be yellow. For better explanation visually, we can see here when we start this to the right. So we have down here where it says system starting, green on for cycle 1, yellow, and then quickly over back to green on the second cycle, yellow, red, and then for the next intersection, it goes green, quickly yellow, red, green for the second one, yellow, red, and that is the end of our loop, which is also seen on the cycle, and it'll continue. But overall, it worked really well for the simulation, and it'll be in the rest of the video you'll see the physical setup we have. And thank you for the semester.
Here is our physical build. It is not finished. It was a lot harder than we thought, and we did not have much time to work out all of the little kinks and stuff. Here is the quick look of the code we used, and we got the LCD screen is working, which would obviously show all of the lights act as a 5-way intersection. The lights are working, but they aren't working with the current code, and some of the problems are mainly so many wires and did not know how to hook them up properly. Yeah, there's a whole bunch of other parts that was going to be used to finish the rest of the project.
Hello, my name is Michael McCleary. And this is our conclusion and lessons learned from our group project. So going through this project, what we have concluded is that using microcontrollers to do something as complex as a traffic light system can be as simple or as complex as you make it. Obviously, in our project as beginners, we essentially just started with 5 intersections and were able to build a virtual working model as far as how that could be done and the code that it would take in order to run it and be able to loop through continuously. The scalability of using a microcontroller for a traffic lighting system can be as scalable as can be, essentially for an entire city to account for, different code might be needed for certain areas that are higher traffic or maybe less traffic, or maybe at different times throughout the day, such as rush hour, having to handle for different algorithms or different patterns in the traffic lighting system. So we really saw that potential of the real world applicability of using a microcontroller for something as complex as a traffic lighting system for a city or multiple cities. Also wanted to touch on a few key lessons that we learned. We did not build in a contingency plan for if our physical build needed to take longer than we originally anticipated for. We essentially, started with a plan. We had regular check-ins. We were able to build a virtual model on the Walkway platform that we thought we could just transition straight over into a physical build. And what we quickly learned is that didn't happen. So building in a contingency as Barrack showed, our project did not come to full fruition on the physical build. So we should have built in more contingency time for physical builds or issues that we were running into to be able to address, triage, troubleshoot, and fix in order for us to meet the deadline for our original project scope. We also had a bit of miscommunication as far as how we could physically meet together. We met virtually as often as we could in order to check in and make sure we were on track. But as we got towards the tail end, noticing that our physical build got behind schedule, having physical support with our team members, especially with 2 of us that were remote and out of state for the summer, and others having, difficulty in schedules, being able to actually meet physically was difficult, and trying to troubleshoot virtually was also difficult. So again, goes back to we just learned that we essentially needed to build in more time for troubleshooting and root cause analysis to figure out how we could get through our physical build, even though we were able to get through our virtual build. So that's the end of our video for today. We are the traffic controllers, and thank you for watching.